So, in college algebra or a previous math course, you have likely seen average rates of change in terms of other types of functions. And so I won't go through all the details of that, but I'll go through the general idea of average rates of change as a refresher. So if you have some function, and here I have a sort of parabolic thing, and you want to know, for example, between this point A and this point B, let's call this function f of x, um, what the average rate of change was of this function. Well, what you want to do is, well, take a look at how high it is at A, how high it is at B, and then how much did it change. So this would be like delta f of x. This over here is delta x, and the average rate of change is the change in your function values over the change in your input or independent variable values. And it's essentially the slope of the line connecting the 2 points, right? Because that's how we find slopes of lines. And so if we're not talking about a sort of parabolic or linear or something function, if we're specifically concerned with circular functions, a natural question we might ask is, all right, as the distance you travel across the circle, let's draw a circle here. Here's a circle. So as you traverse the circle here, as you travel along the circle, how much does your height change? So if I travel across the circle by 1 unit, say, my height changes as well. And we might imagine that this change is different depending on where you are on the circle, right? Like if I go from here to here, then my change in height is very significant. If I go from here to here, and it's probably very small, or even zero if I go up and back down, right? My overall change in height is none in such a case. If I go from here to here, then that change can be very steep. So again, the question we're asking about is, how can we make sense of changes in height over changes in the distance traveled? And so there's only so much that you could get out of drawing on a sort of whiteboard like this. So I built some things here to help illustrate this idea or what's going on here. So what we have here is the unit circle, the circle of radius 1. And what I have graphed here is I have set a point D that stands for how far along the circle we've traveled. So right now we're sitting here, we haven't traveled at all. And D sub D, that's going to be how far ahead I'm going to go next. So in this case, it's set to a quarter of a unit. So if you zoom in here, that's the length of this arc is like 1/4 of a unit across the circle. And so that change is 0.25 because it's set to that. And then we can see how high, how much our change in height is. We're starting from height 0, going up to this height here of 2.47 something. And so that's our change in height. And so the average rate of change across this this particular path is the change in my height over the change in the distance traveled, and that's pretty close to 1. So right now what that's saying is the rate at which I'm traveling is about 1 unit of height per 1 unit of distance traveled. But look what happens as I start to traverse the circle. As I start to traverse the circle, let's say if I come up here, this distance here is still just 0.25, but now my change in height is much less, right? It's now only about 0.18. If you look at the average rate of change here, it's dropped down to about 0.75. And so what that's telling us is our ascent was very steep here, right? We could see that this arc here, like it's coming close to the circle like this, it's super steep. As they start going up and up and up and up and up, and if you've ever been on a roller coaster or a Ferris wheel or something, you'll have noticed this phenomenon too. It like gradually kind of evens out, right? It sort of tops out. And that's going to be what happens as we continue to traverse. We get close to the top, and now my change in height and my change in height per unit is quite small indeed, because I'm close to the top now. And right around here, it's going to be about 0, right? Because now my heights are basically the same before and after. I'm just going over the bump at the top. And what's going to happen next is now my change in height is negative, right? As I traverse, I'm dropping. This is the part where you come down. And so for every 0.25 units I move forward along the circle, my height's dropping by some amount, and that amount increases, and it tops out around here at also about -1, right? It's dropping about 1 unit per unit moving forward. And then, because it's steep here, but then as it comes around, we'll see that it starts to get shallow again, right? So now my changes in height aren't so dramatic. I'm still decreasing because I haven't reached the bottom yet, but it's not decreasing as sharply. And around here, once again, hit something close to 0 before it starts to climb up again, right? And now I'm back to where I started. And so something we should note about this is that first of all, we should note that we go from very steep to shallow to steep negative to shallow to steep again, right? And if I were to continue, if I were to go past a 2-pi rotation, if I were to go to 4 or 6 or 8, we would see this cycle repeat again and again. But notice that the rate of change itself also goes from, while the rate of change, or the average rates of change, are going from about 1 to 0 to -1 to 0 back to 1, my heights are kind of doing something similar, right? So my height's 0, then it's 1, then it's 0, then it's -1 and 0. So the rate of change on the height is itself a periodic function, just like the way that the height is. And that's something that we'll want to take a note of later on in our math careers as we explore these things further. That's something to keep in mind. And here I just have another way of visualizing this. Right here I have the height of the circle function, right, which is the sine, right, of the unit circle. And so I have the changing the distance traveled graphed against the height. So again, as we move forward, all right, if we want to see what the average rate of change is, that's changing height over changing distance, right? So we can see the same things we saw on the circle, right, starting off it's very steep, it's close to 1, and then as I move up, my changing heights get smaller and smaller. As I reach the top here or so, it bottoms out, it gets close to 0, it turns negative. And then it kind of bottoms out again, and it starts to go positive again, right? So this is just a different way of visualizing what we had shown on the circle. But hopefully, all I wanted to communicate with with this video is how we should think about the average rates of change on a circle with the height with respect to the distance, and that is merely just, right, it's steep, shallow, steep, shallow, steep again, positive, and then negative, right? Going up, positive, going down, negative. All right. Thank you very much. If there's any questions about any of this, please, as usual, email me or post in the discussion board, and I'll see you in the next video.